For advanced problems in energy, question 6.7, the diagram is showing us a mass block going down an incline. This part of the incline is curved with a radius r, and then after it goes down this incline, it travels for another 18 meters. Now, the question is asking us what is the frictional force between the crate and the supporting floor. Now, it says both curved and horizontal, so it also says assume the frictional force is constant throughout the entire motion. So throughout this whole thing, there's a frictional force. Now, to find the frictional force, I use conservation of energy. So the energy initial has to equal energy final. Now, at rest, when I say rest, the only energy is potential energy. And then we have to set that equal to the work of friction, because that will like cancel everything out. So initial potential energy equals force of friction times the distance. Now the distance is right over here. It's comprised of x1 and x2. That's what I call this curved incline x1, and the remaining distance x2. So this incline, we're given the radius is equal to 2 meters. So we can figure out this distance, which is 1/4 of the circumference of this circle that we could picture here. And we calculate that is equal to pi. This distance is equal to pi plus 18 meters is the total distance this mass has traveled. Now we plug that into this equation to solve for force of friction, and knowing the mass, we know gravity, we know the height is r since the radius is r, and the distance, we can solve for the frictional force.